Okay, going to week 25 homework. You were either going to simplify expressions or write radical expressions using exponential expressions, meaning to a power. So if you look at this one, you have square root of 10. Recall that when you're using exponential expressions, if you have anything that is a square root, you write it as to the 1/2. If you have a cube root, we would express that as to the 1/3. So in this case, we have the base 10. It is to the square root, so you would enter here your base 10. You would use the exponent feature. Then you can select the fraction, and it would be to the 1/2. There's always the view example feature that also helps. If you check your answer and you exceed the number of check answers, to get full credit, you can go back and hit similar question. It'll produce a new one. If you get that correct, then it'll give you the full points. Let me go forward to the ones that I've been getting most questions about. So something like this. This is the one I've been getting the most questions about. Here you have 8 to the 4/5 and 16 to the 3/5. So as you work on this one here, you're looking at how can I simplify this more? By looking at my options here, or what they have me do. I noticed that they have a base 2. So then I'm going to try to see if I can rewrite these two numbers with a base 2. So if you recall, if you break these up into prime factors, both of these numbers will have only the prime factor of 2. So 8 is the same thing as 2 to the 3rd, because 2 times 2 is 4 times another 2 is 8. So another way I can represent 8 to the 4/5 is 2/3 to the 4/5. 16, I can break it up into 4 times 4 or 2 times 8, and I can keep factoring those out. So 2 to the 4th power is the same thing as 16, and we make that 3 to the 5th power. So if I further simplify this using the power of a power rule, meaning I take the outside power times the inside power, still keeping the base 2. This one here, I would have to do 3 times 4, which is 12. So this becomes 2 to the 12/5. Over here, I do 4 times 3 because it's numerator times numerator. And that also gives me 12. So I get 2 to the 12/5. So here I notice they both end up being the same. They have the same exponents. So here we see that these two, after we simplified, these expressions are equal. The expression 8 to the 4/5 can also be written as we saw here. So this first blank has a 3. And then if we multiply it out, that becomes 2. Whoops. I guess we only want the fraction. 2 to the 12/5. And then we're moving on to 16 to the 3/5 can be written as 2 to the 4th times 3/5, which ends up simplifying to 2 to the 12/5. And then the expressions have the same base, which the base is 2. And they also have the same exponents, so they are equal. Okay, let's check the next one. Here you have 1/3 to the fourth and 1/9 to the second power. Very similar. We can break up the third we can't break up, but the 9 we can represent it since we know it's a perfect square. We could have 1 to the, or 1/3 squared, and that's all to the second power. If we look at these two, I'm not sure if they're still equivalent. I can rewrite this and simplify it and write it with a negative exponent. So if I take this one here, I can write it as 1/3 to the fourth power, or I can distribute the 4 to both the numerator and denominator, so it becomes 1 to the fourth over 3 to the fourth, which is simply 1 over 3 to the fourth. If I want to bring the exponent up, it becomes 3 to the negative fourth. The one that was 9 squared, I guess if I look at this first one, I can write it as 1 squared over 9 squared. 1 times 1 is 1, and I have 9 squared here. If I want to bring this part up to the top using the negative exponent law, I can bring it back up and bring it 9 to the negative second, which now I'm going to use this property here to simplify it with the base of 3. So 9 squared to the negative second. If I do power to a power, this becomes 3 to the negative fourth. So I do see that these are also equal. So they are equal. The expression 1/3 to the fourth power can be written as 3 to the negative fourth after quite some simplifying. 1/9 to the second power could be written as 9 to the negative second, which is equal to 3 to the negative fourth. The expressions have the same base, and they also have the same exponent. So let me clear that out. Here you have the same base. It is a quotient. So we're going to use the quotient property. When we have the same base, we can simplify by subtracting the exponents. So it's always the top exponent minus the bottom one. And 5/3 minus 4/3 would just be 8 to the 1/3. We know that 1/3 is another way to say cube root. So then we're looking for the cube root of 8. 8 happens to be a perfect cube. And 2 times 2 times 2 is 8. So the cube root of 8 gives us 2. So this one simplifies to just a value. And let me clear that out. Here's a product. You're going to simplify this expression using the laws of exponents. You should notice that the base is 2/11. They have different exponents. When I have a product with the same base, the shortcut is I can, let me write this correctly. I can simply just add the exponent. So I have 1/2 plus 3/2. 1/2 plus 3/2 becomes 2/11 to the 4/2, which that exponent can be simplified as 2/11 to the second power, because I really have the entire base of 2/11 to the second power. I can distribute the second power both to the numerator and denominator, making it 2 to the second over 11 to the second. 2 squared is 4, and 11 squared is 121. So this is our final simplified fraction in which we could enter right over here. We have 4 over 121. This one, you do have the same base 10. So for the quotient property, we subtract the exponents. So again, we're going to have the same base. This time we have 9/4 minus. Notice that the denominator exponent is negative, so we're going to subtract a negative 3/4, making this a mega plus. 9 plus 3 is 12/4. 12/4, we actually end up getting a whole number, and that is 3. So 10 to the third power, we do have to simplify it further. That means 10 times 10 times 10. And 10 to the third power is the same thing as 1,000. Okay, and then this last one here, notice that you have the same base 5, or you might have a different value than 5. But we do know that because it's a product, we have to add our exponents. In this particular example, we have x over 2. We have to add x to the 6th power. Notice I'm not writing the base number at all. Those two exponents need to add up to 8. Now this becomes a simple, or simply an equation that we need to solve. From elementary school, if you recall, we can add fractions if they have different denominators. So I'm going to make both of them be add of sixths. So this one we have to multiply both the numerator and the denominator by 3 to keep it equivalent. Since the second one, the denominator stayed 6, the numerator just stays an x. So 3/6 plus another 6, because recall there's a coefficient of 1 here when there's not 1. So this becomes 4/6 x is equal to 8. To get x isolated by itself, we do have to multiply by the reciprocal. So we're going to multiply by 6/4 on both sides. Whatever we do to one side of the equation, we have to do to the other. So I'm going to make this 8 a fraction by putting 8 over 1. I do see I can cross reduce here. 4 goes into 4 once. 4 goes into 8 twice, leaving me with 2 times 6. And since it's over 1, that just equals 12. Some of you might have the version where it's a simplified fraction and you leave your answer as a fraction. And if you would like more support, you can always come and see me in the classroom. I will gladly work with you. I noticed that if I just hit another similar problem, now I have x over 2 plus x to the 5th is equal to 4. So if you want the additional practice, even if you get it right, you can always hit similar problem to continue practicing.